Question. DS. If a right triangle ABC has a hypotenuse of 10 inches and angle ACB equals 90 degrees, what is the area of the triangle ABC in square inches? Condition 1. The length of the line segment AC is 8 inches. Condition 2. Side AC's length is 2 inches longer than side BC's length. Solution. Now we will solve this DS question using the variable approach. DS, 3 variables and 2 equations. Question. Condition 1, 1 equation. Condition 2, 1 equation. DS question with 3 variables and 2 equations. Let the original condition in a DS question contain 3 variables and 2 equations. Now, 3 variables and 2 equations would generally require 1 more equation for us to be able to solve for the value of the variables. We know that each condition would usually give us an equation, and since we need 1 equation to match the number of variables and equations in the original condition, the equal number of equations and variables should logically lead to answer D. Wow! You can also solve geometry questions using the variable approach. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find the area of the triangle ABC in square inches if a right triangle ABC has a hypotenuse of 10 inches and angle ACB equals 90 degrees. Let the other 2 sides be A and B, and the hypotenuse be C. Because it is a right-angled triangle, we can use Pythagorean Theorem, which is a squared plus b squared equals c squared. Follow the second and third steps. From the original condition, we have 3 variables, a, b, and c, and 2 equations, a squared plus b squared equals c squared, and c equals 10. To match the number of variables with the number of equations, we need 1 more equation. Since conditions 1 and 2 will provide 1 equation each, D would most likely be the answer. Don't forget Pythagorean Theorem. It is your friend and very helpful in many different situations. Recall 3 principles and choose D as the most likely answer. Let's take a look at each condition. Remember, you don't have to do this work on the actual exam if you are stuck. Simply pick the answer D and move on to the next question. Condition 1 tells us that the length of the line segment AC is 8 inches. That is, B equals 8. Therefore, we get A squared plus 8 squared equals 10 squared. A squared equals 100 minus 64 equals 36, or A equals square root of 36, which equals 6. Area of a triangle is 1/2 times the base times the height. So, the area is 1/2 times 8 times 6, which equals 24 square inches. Since it is a unique answer, this condition is sufficient. Condition 2 tells us that the side AC's length is 2 inches longer than the side BC's. That is, B equals A plus 2. Substituting this in original condition A squared plus B squared equals C squared, we get A squared plus whole of A plus 2 squared equals 10 squared. We need to FOIL out whole of A plus 2 times of whole A plus 2, which gives us A squared plus 4 times A plus 4. So the equation becomes A squared plus 4 times A plus 4 equals 100, or 2 times A squared plus 4 times A plus 4 equals 100. Now by dividing the equation by 2, we get A squared plus 2 times A plus 2 equals 50. Bringing the 50 over gives us A squared plus 2 times A minus 48 equals 0. We need to factor this by finding 2 numbers that multiply to negative 48 and add 2. Possible numbers are 8 and negative 6. The equation becomes whole of a plus 8 times of whole a minus 6 equals 0. So a can be 6 or negative 8. As the length cannot be negative, a will be 6. Since it is a unique answer, this condition is sufficient. You're going to learn how to get these answers in the next lessons. We are the first people in the world who can solve geometry questions using the variable approach. Don't forget that a triangle has 3 variables. Each condition alone is sufficient, so D is the correct answer.